All right, January 2018, question 10b. It says the diagram below shows a cuboid. All right, now give your answers correct to one decimal place. I, it says a straight adjustable wire connects R to P. A straight adjustable wire connects R to P along the top of the cuboid. Calculate the length of the wire RP. So they're saying to us that a straight adjustable wire connects R to P, and we're to calculate the length of that line. A few things to bear in mind. If this is 100, this is also 100, and over here is also 100. All right. All right, so what I'm going to do is I'm going to draw, um, so what we have here is a three-dimensional view of the cuboid. I'm going to draw a two-dimensional view of the top of the cuboid. Now, this cuboid here has a total of 6 surfaces, and all 6 surfaces are, from what I can see, all 6 surfaces are rectangles. So I'm going to draw a um, just an illustration of an illustration. And essentially, I want the thing to look more familiar to me. So now I have Q here, R, um, P, and I have S. So this is the top of my cuboid. This is 60 centimeters. We'll already show that QP is 100 centimeters. And we're asked to find the length of QR. All right, it's a cuboid, and I told already all the surfaces are rectangles, so that angle there is 90 degrees. So this is a right angle triangle, and the tools for solving a right angle triangle are Pythagoras theorem and the trig ratios. Now, if I know two sides of a right angle triangle and I wish to find the length of the third side, I'm going to use Pythagoras theorem. So let's put an X here. Now, this is my Pythagoras theorem formula. A square is equal to b square plus c square. A in the formula is the hypotenuse, and b and c are the other two sides. So here the hypotenuse is what I want to find, PR, and it is x. So I have x squared is equal to 60 squared plus 100 squared. Those are the other two sides. This is what, 3,600 plus, let us say, 10,000. So this is 13,600. That's x squared. The opposite of square is square root. So x, which is PR, is equal to the square root of 600. Now, let's see what that is. So this is 116.6. So PR is 116.6, and the length is in centimeters. All right, so that's the first thing we're asked to do. We're asked to find PR. Then we're asked to, it says the connection at P is now adjusted and moved to T. So the connection at P is now adjusted and moved to T. We're to calculate the length of the wire RT. Alright, so what I did is that, remember they told us that this is an adjustable wire. And all that's simple to know is what? So the connection at P is now adjusted and moved to T. So all it did is the Y is now drawn, no, not from R to P, it's now going from R to T. All right. Now, so it'd be good if you guys could see this. All right, so let's just draw a line here and draw a line here. So what I'm looking at is that what I've just did is I've just connected the diagonal from what P to R and from T to V. By connecting the diagonals from P to R and T to V, what I've done is I've created another rectangle. The rectangle is PRVT. PRVT is a rectangle and RT is a diagonal. So let's draw a sketch of that. All right, so this is PRVT, PR, V, and T. PT, I believe, is what, 20 centimeters. So we can put that in. This is 20 centimeters. I think we got PR to be 116.6 centimeters. And we're now asked to calculate the length RT. It would be nice if we could draw some really nice straight lines. All right, again, this is what straight Pythagoras theorem. All right, and so let's call RTY. This is my right angle. I'm going to have what y squared is equal to, y is the hypotenuse, is equal to 20 square plus my 116.6 square. 20 square is 400 and 116.6 square is 13,600. Remember, we got the 116.6 by finding the square root of 13,600. So it means that 116.6 square is 13,600. So this is 14,000. All right, and this is y square. The opposite of square is square root. So y, which is rt, is equal to the square root of 14,000. So the square root of 14,000 and the square root of 14,000. This says 20 root 35. I don't want to answer like that. All right, so the answer is 118.3 centimeters. So RT is 118.3 centimeters. Let's see if we can finish the question. We're asked to calculate angle TRV, angle TRV, angle TRV. Angle TRV, we're being asked to calculate this angle here. We're being asked to calculate this angle here. This is a right angle, so let's call here theta. All right, I know that down here is 116.6 and over here is 20. This side here is opposite to my theta and this side is the adjacent side. The ratio that includes opposite and adjacent is tan. So I can say that the tangent of theta is opposite 116.6 over the adjacent side, which is 20. If I know the tangent of an angle, to find the angle, I'm going to use tan inverse. So theta is equal to tan inverse 116.6 divided by 20. So theta, which is angle TRV, TRV would be equal to, let's find it out. So it's shift tan open bracket 116.6 over 20 close bracket, and then press equal. So this is 80.3 degrees. This is 80.3 degrees. All right, let's see what else they have in store for us. So this is triple I. I'm guessing that this was II. All right. The fourth thing, they ask us to complete the following statements. It says the size of the angle through which the wire move from PR to RT is the size of the angle through which the wire moves from RP to RT. So what they're asking us is that in moving from PR to RT, what is the size the angle moved through? What is the size of the angle that the wire moved through? So that would be this angle here, because PR is like you're dropping PR for it to become what? Sorry, you're dropping RP for it to become RT, and the angle it moved through is this angle here, alpha. So that angle there, IV, the angle. All right, I don't want to write the entire sentence. I'll just write the angle. The size the angle through which the wire move from RP to RT is equal to 90 minus the 80.3, and so that angle would be equal to 9.7 degrees. Next, the angle which is the same as RTV. The angle that is the same as RTV. The angle that is the same as RTV. RTV is this angle here. All right. The angle that is the same as RTV is, well, angle RTV is equal to RTV is equal to, these two angles are equal here. These two angles here and here. This angle here, this angle here, they're equal, they're alternate angles. So RTV is the same as angle what? TRP. So it's the same, this is equal to angle TRP, and they are alternate angles. All right.